Now we'll discuss unit number 3, which contains gamma function, beta function, error function, DUIS. Okay. So first we'll discuss gamma function. As a reduction formulae we already discussed in the class. So here we'll discuss gamma function first. So the definite integration from 0 to infinity e to the power minus x into x to the power n minus 1 dx n greater than 0 is defined as gamma function, and it is denoted by this notation gamma n. Therefore, see, integral from 0 to infinity e to the power minus x to the power n minus 1 into dx is gamma n. So value of this integration is gamma n. So this gamma function is useful to find out the more complicated integrations. Here we'll discuss the properties of gamma function. First, gamma 1. So we'll see the value of gamma 1 here. So gamma 1 substitute n is equals to 1 in this definition. So we'll get integration from 0 to infinity e to the power minus x dx, and if we solve this integration we'll get value 1. So first property, gamma 1 is equals to 1. The second, say if we substitute x is equals to kt in the definition of gamma function n, you'll get a transformation of this gamma function. Say x is equals to kt, so dx is kdt. Limits when x is 0, t is 0, when x is infinity, t is infinity. Therefore substitute these values in gamma function. So gamma n 0 to infinity e to the power minus x is kt, so minus kt, x is kt, so this kt to the power n minus 1, and dx is kdt. So it is k to the power n, say k to the power n minus 1 into this k. So k is constant, so we'll take it outside. So we'll have 0 to infinity e to the power minus kt t to the power n minus 1 dt. Therefore, see, value of this integration is gamma n by k to the power n. You transfer this k to the power n to this side. And we know that change of variables are immaterial in finite integration. So we'll replace this t by k. So integration from 0 to infinity e to the power minus kx x to the power n minus 1 dx is gamma n by k to the power n. And this result is important to evaluate the integrations. Okay. So either we'll use this definition or this transformation. Now, third, we'll find out the reduction formula. Reduction formula for gamma function. Okay. So to get reduction formula, we'll start from gamma n plus 1 is equals to 0 to infinity e to the power minus x, x to the power n is replaced by n plus 1 minus 1, so it is n dx. Now we'll evaluate this integration by parts. So first function is x to the power n algebraic, second is exponential. So x to the power n as it is into integration of e to the power minus x is e to the power minus x by minus 1. Limits from 0 to infinity minus differentiation of x to the power n is n into x to the power n minus 1 into integration of v, that is integration of e to the power minus x is e to the power minus x divided by minus 1. So this minus and this minus becomes plus. So we'll get n 0 to infinity e to the power minus x x to the power n minus 1 dx, and this is nothing but the gamma n. So this is the reduction formula. Gamma n plus 1 is equals to n into gamma n. So here, if your n is suppose integer, then see value of gamma n will be from this reduction formula. So gamma n plus 1 is n into gamma n, and therefore value of gamma n from this reduction formula is n minus 1 into gamma n minus 1. Then value of gamma n minus 1 is n minus 2 into gamma n minus 2. Then gamma n minus 2 is n minus 3 into gamma n minus 3, and continue this till gamma 3. So gamma 3, gamma 2, gamma 1, like this, since n is a positive integer. Okay. So here n positive integer, we have defined that gamma function for n strictly greater than 0. So what's a gamma 3? Gamma 3 is 2 into gamma 2. So gamma 2 is 1 into gamma 1, and gamma 1 is 1. So if you substitute these values here, so what you'll get, gamma n plus 1 equals to n into gamma n, but gamma n is n minus 1 into gamma n minus 1, but gamma n minus 1 is n minus 2 into gamma n minus 2, and so on up to 3 into 2 into 1. So what we are getting, factorial n. So gamma n plus 1 is factorial n if n is positive integer. So we can write this reduction formula, or we can write this result as gamma n plus 1 is equals to n factorial if n is positive integer and it is n into gamma n otherwise, right? So this result is important here, okay, to find out the value of gamma n. So next result, or next property, say gamma 0 is infinity. So gamma 0 is not defined here because see gamma n is gamma n plus 1 by n. From reduction formula we have this. So substitute n is equals to 0 here. So we'll get gamma 1 by 0, and gamma 1 is 1. So 1 by 0 is infinity. So gamma 0 is not defined. It is infinity. Next result, gamma half is root pi. So gamma half is root pi. So we'll see it proof later on after discussing beta function why this gamma half is root pi. The next property, gamma p into gamma 1 minus p is pi by sine p pi, where p varies from 0 to 1. So this p should vary between 0 to 1. Then and then we'll apply this result there. Gamma p, gamma 1 minus p is equals to pi by sine p pi. Now we'll discuss that how to evaluate the values of gamma n. See, gamma phi. So we have this result here, right? Gamma n plus 1 is factorial n if n is positive integer, or it is n into gamma n otherwise. So gamma phi, so phi is an integer, positive integer, so what it is, 4 factorial. This gamma phi can be written as, see, phi can be written as 4 plus 1, so it is 4 factorial, like gamma 100, 99 factorial, and so on. Okay. Now since we have gamma half, value of gamma half, which is root pi, therefore we can find out, or we can evaluate all the values of gamma. Therefore we can evaluate here gamma 3 by 2, like gamma 5 by 2, gamma 9 by 2, and so on. So say gamma 3 by 2, so this 3 by 2 can be written as 1 by 2 plus 1. So using reduction formula, this is n into gamma n, so half into gamma half. So half into gamma half is root pi. So value of gamma 3 by 2 is half into root pi. Similarly, we can find out gamma 5 by 2. So gamma 5 by 2, 5 by 2 can be written as 3 by 2 plus 1. So it is 3 by 2 into gamma 3 by 2. So 3 by 2 into, say gamma 3 by 2 is half into root pi, and so on. Okay, so in this way we can find out the values of gamma 7 by 2, gamma 11 by 2, and so on. If somebody asks you to evaluate the value of, say, gamma half, then in this case we'll use this result, gamma n plus 1, this reduction formula, is equals to n into gamma n, as gamma n is equals to gamma n plus 1 by n. So using this result, gamma minus half, so n is minus half, so we'll get gamma minus half plus 1 divided by minus half. So gamma minus half plus 1 is gamma half divided by minus half, so this is minus 2 into gamma half is root pi, right? So in this way we can find out the values of gamma functions. Now we'll discuss the examples. So first example, evaluate integral from 0 to infinity root x into e to the power minus cube root of x dx. So here we'll use these two definitions to evaluate these integrals. Integration from 0 to infinity e to the power minus x, x to the power n minus 1 is gamma n, or integration from 0 to infinity e to the power minus kx into x to the power n minus 1 is gamma n by k to the power n. So generally we use this second result. So this first example, if we compare it with the gamma function contains, see the integrand function in gamma function, what is it? Exponential and algebraic. So algebraic and exponential function is there in the integrand function in the integration of gamma function. So here algebraic and exponential, but this exponential has power minus x or minus kx only. So we have here power as cube root of x, minus cube root of x. So we'll convert this power to either minus x or minus kx. Okay, so here to convert this power to minus x, we'll substitute this cube root of x is equals to t. This implies, say, cube root of x is t, therefore x is equals to t cube. Therefore dx is 3t square dt. So see the limits, x, new limits of t. So when x is 0, t is 0. When x is infinity, t is infinity. Therefore this integral is new limits are from 0 to infinity, root x. Root x means x to the power half. But what is the value of x? T cube. So t cube to the power half into e to the power minus cube root of x is t. So e to the power minus t into dx. Dx is 3t square dt. Okay. So simplify this integrand function. Here t cube to the power half is t to the power 3 by 2 e to the power minus t. This 3 can be taken outside into t square dt. So it is 3 integral from 0 to infinity this e to the power minus t. Now here t to the power 3 by 2 into t square is t to the power 7 by 2 into dt. Alright. So if we compare it with gamma function, we have exponential function and algebraic function. Okay. So algebraic function has power in the form of n minus 1. So this power 7 by 2, we'll write it in the form of n minus 1. So 3 integral from 0 to infinity e to the power minus t to the power 7 by 2 plus 1 minus 1. We'll add and subtract 1 there. So we'll have 3 integral from 0 to infinity e to the power minus t into t to the power 7 by 2 plus 1, 9 by 2 minus 1 into dt. Now compare this with the gamma function e to the power minus x, x to the power n minus 1. So e to the power minus t to the power 9 by 2 minus 1. So n is 9 by 2 here. So what we'll have using a gamma function, value of this integration is gamma 9 by 2. And we can evaluate gamma 9 by 2 easily. See, gamma 9 by 2. So 9 by 2 can be written as 7 by 2 plus 1. So it is 7 by 2 into gamma 7 by 2. Again 7 by 2 can be written as 5 by 2 plus 1. So it is 5 by 2 into gamma 5 by 2. Then 3 by 2 into gamma 3 by 2. Then 1 by 2 into gamma 1 by 2. And gamma 1 by 2 is root pi. So you can find out this value, you can calculate this value, and which is 315 by 16 into root pi. This is example 2. Integral from 0 to 1 x divided by a root of log 1 by x dx, ln 1 by x dx. So see, to use gamma function, what should be your integrand function? It should be algebraic and exponential. So here algebraic function is there, but see, another function is a logarithmic function. So we'll convert this logarithmic into exponential. So to convert it into exponential function, what we need to take? We need to take this transformation or this substitution. Put log 1 by x is equals to t. Therefore 1 by x is e to the power t, and therefore x is e to the power minus t. Therefore dx is minus e to the power minus t into dt. So see the limits simultaneously. X t. So when x is 0, see, when x is 0, so 1 by 0 is infinity, and log infinity is defined to be infinity. When x is 1, log 1 is 0, so t is 0. So see this integration, So new limits are from infinity to 0. X, so x is e to the power minus t into 1 upon root log 1 by x, but log 1 by x is t, so it's a root t into dx. Dx is minus e to the power minus t dt. So this is equals to, see, I can change this limits from infinity to 0 as 0 to infinity, and I'll attach negative sign. So this negative and this negative will be positive. So we'll have e to the power minus 2t into 1 upon root t, but root t means t to the power half. So 1 upon t to the power half is t to the power minus half into dt. So say we have exponential function and algebraic function here. So we'll use this second definition. E to the power minus kx, x to the power n minus 1 dx is gamma n by k to the power n, right? So here if we compare it with that, here k is 2 and n. So we'll find out that n, this power, we'll write it in the form of n minus 1. So it is 0 to infinity e to the power minus 2t t to the power minus half plus 1 minus 1 dt. So it is 0 to infinity e to the power minus 2t t to the power half minus 1 dt. Therefore, see the value of this integration using that second definition, k is 2, n is half, so it is gamma half divided by k to the power n, that is 2 to the power half. So gamma half is root pi, so this is root pi by 2 to the power half means root 2, so this is equals to root pi by 2. Example 3. Third example, integral from 0 to infinity x to the power 4 by 4 to the power x into dx. So here x to the power 4 algebraic function, 4 to the power x, this is exponential function. See, you know, a to the power x, it is exponential function. Why? Because this can be written as e to the power log of a to the power x, that is e to the power ln of a to the power x. So e and ln get cancelled, you get a to the power x again. So this is e to the power x into ln a. So using this 4 to the power x can be written as e to the power ln 4 to the power x, that is e to the power x into ln 4. So substitute this value here. So what we'll get? Integral from 0 to infinity x to the power 4 into 1 upon 4 to the power x is e to the power x into ln 4 into dx. So this is equals to integral from 0 to infinity. So 1 upon x into ln 4 is 1 upon e to the power x into ln 4 is e to the power minus x into ln 4 into x to the power 4 dx. So here log 4 is constant, so it is k, and x to the power 4 means it can be written as 5 minus 1, so n is 5. So here we are going to use this second definition again. Okay. Say integral from 0 to infinity e to the power minus log 4 into x to the power 5 minus 1 dx. So using that second definition, what's the value? Gamma n divided by k to the power n. So here n is 5, k is log 4. So it is gamma 5 divided by k to the power 5, like log 4 to the power 5. And gamma 5 is 4 factorial divided by ln 4 to the power 5. So it is 24 divided by ln 4 to the power 5, right? So now here you'll be able to solve now all the examples of gamma function. Okay, we'll see these additional examples. Evaluate integration from 0 to infinity a to the power minus 4x square dx. So here we have exponential function, we don't have algebraic, so you need not worry about that. See this exponential function, we'll write it in the form of e first. So let I be integration from 0 to infinity a to the power minus 4x square dx. So see this e to the power minus 4x square can be written as e to the power ln of a to the power minus 4x square, that is e to the power minus 4x square into ln a. So we'll substitute this value here. So I is equals to integral from 0 to infinity e to the power minus 4x square ln a dx. So if you see the power of this exponential term, so it has 4 log a and x square. So what we have in the definition, e to the power minus kx. So we'll try to use this definition there. So here k into x is there. So what we have, k is 4 into log a, but coefficient is x square there. See, e to the power minus 4